So let's do another practice for one-way ANOVA. So girls from 4 different soccer teams are to be tested for mean goals scored per game. The entries in the table are the goals per game for the different teams. At the 0.10 level of significance are the mean goals scored similar among the different teams. So they're comparing 4 teams to see how many times they score per game. They do this a lot in sports, especially when people are betting or looking at odds on football, basketball, soccer, anything like that. They will look at the average goals, bases, anything like that. Anywhere that there's some kind of point given, they'll always look at the averages to see. So for this, they're going to see, is there any difference in the average goals between team 1, team 2, team 3, and team 4? And as you see, they have those individual goal score, those individual games scores at the end to see how many goals they scored. Okay, so how many teams are we looking at? We're looking at 4. It's really easy to see. And how do I know that? Because it's divided into 4 different groups. So I'm going to put teams and I'm going to put 4. You could write it differently, okay? So is there quantitative or qualitative data? I'm going to do quantitative. Why am I going to do quantitative data? Okay. Even though these are divided into categories, the data itself is quantitative because it's number of goals, because I can average the number of goals, I can divide by the number of goals, those kind of things. I can do regular math with the number of goals we have. So what's the null hypothesis? Well, actually, the great thing is it's already up here in my problem. And all I have to do is I just need to bring it down. So HO is the mean goals scored are similar among the different teams. That's my null. So what would my alternative be? I'm going to do this again, but I'm going to change a few of the words. The mean goals scored are not similar. Okay, remember, similar means they kind of equal each other. Remember, equal sign go in the null hypothesis. Not equals go into the alternative. So the mean goals scored are similar among the different teams is the null, and the alternative is that they're not similar. Okay, so I've got my null and my alternative, and I'll put this back up here so we can just get it out of the way so that I have those together. Okay, so the next thing it wants to know my F statistic and my p-value. I go to Minitab. I already have my teams in there. I just copied and pasted the data. I go to Stat. I go to ANOVA, one way, and I need to go here. When you do this, the default might be like this. Well, I can't do this because remember when I did that, my data was in one column and the categories were in the next column. So if I do it with this, response data are in separate columns for each factor. Now I can see there's team 1, team 2, team 3, team 4. My options, I've got to change this to 90 because I had a 10% level of significance. Again, I check assume equal variances and then it's a 2-sided. I hit OK. So again, it gives me my hypotheses. It shows me that I chose all 4, and you want to make sure that you're including all the data you need to include. So this is a really good check to show, okay, I did have 4 levels or 4 categories for this. So let me copy what I got for my statistics. Copy the picture, and I'm going to put it here so I can start dissecting what I got. Okay, and I'll go back to Minitab right quickly and see what else I have. I've got the means of each group if I wanted to. I don't think I did it in the last practice problem video, but I'm going to show you this. If for some reason I ask, I'm going to put it down here, for the average of each team, I can see here for team 1, I had 5 in that sample, and my average was 3.4 with a sample standard deviation of 0.894. And you can do it for any of the groups or the factors that we have, and we even have the confidence interval here, the 90%, so that's kind of useful. Go back to Minitab again, I keep going down, and here's my graph, and you can see there is some differences. Let me copy that so we can look at it better when I take it over, because I think this might actually be different. Let's look. So let me put it here. Okay, so team 1 did really good. They scored a lot of goals. Team 2 and 3 are pretty similar, but team 4, they don't look like they scored as many, because if I look across, it looked like the average for team 4 was under 1, and the average for team 1 was around 3.5. And again, I can go to my actual means. Oh, I was pretty close. Team 1, the average was 3.4, and team 4, it was 0.8. So again, these values right here, these means and these teams, are what's showing down here. And a cool thing here is, let me see if I can put it in the screen. For team 4, here is the mean, and here is the upper bound of that confidence interval, and here's the lower bound. Okay, again, I think something's going on. While these are similar, team 1 and team 4 are very different. All right, so what is my F statistic? I'm going to put it right here. It's 3.66. What is my p-value? 0.035. So I'm going to compare it here. Let me bring up more room. All right, so 0.035 compared to, let me put more room, 0.10. Okay, 100 is greater than 35. So this is I'm going to put in the correct symbol so I know. So then I reject the null. Okay, so what does that mean if I reject the null? So this one is false and this one is true. Okay, so that tells me that the mean goals scored are not similar among the different teams. So I'm going to put that as my conclusion right here. Okay, I'm just copying my alternative again, and all I'm going to do is at the 10% level of significance. The mean goal scored were not similar. Okay, so what does that tell me? That, again, my hunch when I looked at my graph is something's going on, but I cannot tell exactly which ones are different unless I run another test. And that's for a later statistics class. There's these tests called ad hoc that we can look at to see the differences. I'm guessing it's probably the differences 1 and 4. If I compare those together, they're different. So that's another thing I need to think about. But there could be differences in 3 and 4, or even 3 and 2. Those kind of things I need to look at. But that's why I use an ad hoc test.